Hello, everybody. Thank you for coming. I'm happy to see you here. My name is Artem, and I'm a medical doctor from Ukraine. 4 years ago, I made an oath to help those in need. And I thought, if I'm to help people, I might as well start from front end, right? So here I am now, and I'm a full-stack developer, and I'm extremely honored to speak at React Finland and, most importantly, help you creating layouts that last. As web developers, we create user interfaces knowing that it's the primary surface of interactions of users with our application. So it's obvious that we want to build reliable and reusable and maintainable systems. And today in this talk, I would like to analyze the layouts we build from maintenance point of view. And by that, I mean a certain set of factors. So first of all is how much time do I need to spend to understand a certain layout piece? Is it a minute? Is it a week? Then how many things do I actually need to change in order to implement a new feature or fix a bug? And then how well can I predict my changes? Is it going to be a scoped change, or am I going to fix one thing and break 10 more? But first, let's know our enemy. Let's know layout. Layout consists of components that we have and spacing that we use to distribute these components, to define relationship and position. Now, there are a lot of great materials on how to build reusable and maintainable components, especially in React. But what I think we often neglect is spacing. Just think about it, how much time you spend thinking through your Atom components and that they work over the time you spent making sure the spacing is right. It was quite a bad ratio for me. So this is why I started to wonder, why is that so? And this is because I believe that spacing is #1 reason why layout maintenance fails in the long run. And I'm speaking about maintaining applications we build through years. And this is because of a reason. There are certain problems and challenges that we face as developers when working with spaces. First of all, spacing has multi-factor nature. There's often multiple things that affect spacing. Take a look at this example. This is a small schematics of a card component, and we can see right away that there is some internal spacing. There is probably padding from the container, and then there is spacing between left and right columns, and then spacing between text and heading. And then there is a button which doesn't seem to follow anything. It's just vertically aligned to the bottom. So you can see even at such a small unit how spacing can be hard. Then spacing is often contextual. We can have the very same set of elements, and they will be differently positioned and spaced based on different context, for example, a viewport. But what we end up doing is that we creating different variations of our components to satisfy those contexts, and thus effectively bringing context to the small units that are supposed to be reusable. And to make it worse, there is no single way how to declare spacing in our apps. Of course, you can say, hey, we have padding, margin, and a lot of other CSS props. And that's true, but it's the same as saying that document create element is enough to build efficient JavaScript interfaces. Of course, it's used under the hood, but what we miss is high-level API for spatial distribution. The same way React does for interfaces, we miss an API that would encourage us and lead us and restrict us if it's necessary to make sure that we build proper layouts that last. Bottom line, spacing is hard. It's always been, and I think it shouldn't have been. I was thinking, what if we can define relationship between our components using some sort of abstract syntax? Just kind of write that I want a header, and I want a content, and a footer. And I would get this one-column layout, just using some words. And maybe I want to complicate things a little bit, just have 2 columns of things, like with aside and footer. That would be cool. It would be also great if it would support even crazy layouts, because this is what we often do during support. Things changed and new requirements come, and this would be really cool to have such thing, right? And we do have it. It's CSS Grid. For those of you who are not familiar, CSS Grid is 2-dimensional display model in CSS that allows us to build grids by specifying rows and columns and place our content within this rows, columns, or areas. It's been around for a few years, and it's really well supported, so I encourage you to use it today. And this example you saw, it's just me using CSS grid template areas, which you can do right now in the browser. No hacks. But I was thinking, what if we take CSS Grid, which is a remarkable piece of technology on its own, and we combine it with React and JavaScript and features we have there. And I'm really excited to share the outcome of my small project, which is called Atomic Layout. Atomic Layout is physical representation of layout composition. So it's composition like a React component that you can render, configure through props, and reuse in your apps. So here's a quick example. So we're able to import composition from Atomic Layout, and then we can define some custom component. I could say I want a header, and header is a composition of the following areas: logo, menu, and actions. Left to right, inline, very easy and nicely to read. Once I do so, I can use render prop, and Atomic Layout will give me React components based on these areas that I specified. And these components are already tied to the areas, so they position in the interfaces right. And I can render them as children of my composition. And of course, as any React component, I can render another component inside, including another composition, which creates beautiful nesting. And I would like to focus on some features that JavaScript and React allows us to do. Well, first one would be unification. Imagine if you can go to any part of your app, to some layout definition, and immediately understand how it's written, how does it look like, what I need to do to change it, and what would be when I change it. And this is what we can have with Atomic Layout. We can have template definitions. So I have a template for mobile, and it's just one column. And then I see a template for desktop, and it's two columns, and new areas are introduced. And then I can see the rendering part in the same module, which uses these areas. And it just renders them, so it's very clear to me what's happening and how can I change it. Then there is a small feature which we can use. It's prop aliases, and it's basically aliasing of certain properties in React, for example, like padding horizontal, which we can write, and they will emit slightly more complicated CSS, like padding left and right, in this case, with the same value. And there are plenty of those just to speed up our development. Then there is a feature specific to Atomic Layout, and this is responsive props. It's a concept that you can have a prop name, and you can suffix it with a breakpoint name, and the value of this prop will be automatically applied only at that breakpoint and up. So here's a quick demo. We have a box component, and we can say that we want to have a padding of 10 pixels. Good? And if I want to increase the padding as my screen size increases, I just write padding small is 20 pixels, and it's applied automatically. The same way, I can control behavior, how it's applied. So I can have flex direction of column applied from medium breakpoints and down. And I can trigger specific breakpoints, so I can have 20 pixels of margin only on large screens. And all this is just small, concise API to manage different responsive values and how they change without having to write media queries. That is consistent because these breakpoints are defined in the global layout settings. I believe that when dealing with layouts, we often come to the point when we need to render something based on certain condition. We often use viewport as a condition. And I feel that this is such an essential thing we do every day that it needs to come built into tools that we use. So there are two main ways to render things conditionally with Atomic Layout. The first one would be using a dedicated only component, where you can specify that you want to render children only from certain breakpoint. Like I want to render this only from large breakpoint and up. You can target specific ranges of breakpoints. So I want to render children of this component from small to medium or large breakpoint. And you can use special except prop that would flip the condition you specify and render everywhere except, for example, medium breakpoint. And again, in a very short manner, being high-level API over media queries and CSS that's generated. The second way to render things based on condition would be using responsive areas. So we have a composition here. And remember that responsive props feature? So we can use it here. We can specify the mobile layout, for example, of logo and menu. And then we can specify areas MD, so from medium breakpoint, to have 2 columns. And there is a new search section underneath. And apart from these 2 strings being applied based on media query, atomic layout will parse them and understand that logo and menu are present everywhere, so just render them. But search is only defined on medium breakpoint with areas MD, so it will automatically wrap it into media query container and render only when you specified. Of course, different projects demand different needs, so this library comes with range-wide set of configurations. You can set default measurement units. For example, I'm a big fan of basing my spacing on typography, so I often use rems and ems. Then you can specify default responsive behaviors for responsive props, and also custom breakpoints. Now I would like to focus on differences. Like, this all is great, but we're certainly seeing this part somewhere. How is this actually different from everything we saw before? Well, the main difference would be that atomic layout leverages concept of composition, and you become thinking in composition. So layouts is no longer a bunch of utils and CSS properties you need just to clunk together to work. You become to describe layouts like composition of things, and this is how you actually write the code. So a page component becomes a composition of header, content, and footer, and header becomes composition of logo, menu, and actions. And menu may be just a composition of React components, why not? It's like a grid that goes all the way down to the very furthest leaves of an interface tree, and it remains predictable, has the same declaration, and it's very easy to read. One more difference would be the fact that this approach introduces the separation of concerns. It gives you a dedicated layer to declare your spacing and relationship between units without actually knowing what you're going to render. And then there's a rendering part where you can use your atom components and they know nothing about spacing, so you can switch them and reuse them. Technically speaking, atomic layout is built currently with style components. So the way it works is that CSS generated by the library is scoped to the component where you define it. So there is no way that you can be changing one place and accidentally breaking another. And all this gains us really great maintenance because it's easy to read our layouts, because there's separation of responsibilities, and we are sure that we can't break things, we just define things declaratively and then render what we want. And also, one of the main goals would be that atomic layout is meant to be a fun way to learn CSS grid. This is the reason why the API and the props you write and the values you give, they resemble CSS close to one-to-one. Because I want you to learn concepts, not tools. Concepts that you can apply even without any libraries, just with raw CSS or even thinking patterns. This has all been great, but I would like to give a short demo of what it looks like to actually code with atomic layout. Okay, so can you see the code? Probably, yeah. So I have a small app that renders the list of apartments in Finland. And I have them in JSON, and I just have a flat list component that renders flat component, and the flat is just the title and location of an apartment. This is good. You can see the rendering on the right. But let's start to bring some UI and some spacing here. So, as you know, we can start from importing composition. Then I need to declare how is this component going to look like. So I'm going to create a template string. So I want to have a mobile view, which will be a thumbnail, some heading, and actions, just in one column. Then I would render the composition, and I would specify this template string as the areas prop value, so like that. Now I can access all these areas like React components, thumbnail, heading, and actions. And yeah, I can just render them. I will move some data inside. Yep. So I have this composition defined right now. So I have a template string, and I have a rendering part, the composition. Now I would use a few predefined Atom components that are just visuals. They don't know anything about spacing. So I will wrap things in the card component. Use an image for the flats, so image. And I would render some button here to book the flat. So let's hit save. So immediately things became more appealing. So we have these components, we have the definition of the areas, we just miss spacing. So let's add it. We have a whole layer here that is responsible for spacing. So I will add the padding first, and I will space out the elements inside our grid. Something like this. Looks much better now. And the great part about the templates is that we can move the areas around, and our spacing doesn't break. Because our components don't care about spacing, only the composition is specifying the spacing. But you can move things around, which I think is great for maintenance. But I would like to move this concept even further. If we think about this flat list is just a composition of flats, right? So let's apply the same principle here. We'll take the composition, and render it here. Now, for this use case, I don't think that it makes sense to specify areas. There's effectively one area which is just dynamically repeating. So what I can do instead is just specify how my grid is going to look like. So I can say that I want it to have columns, and I want it to repeat content as much as it fits, as long as each item is 250 pixels wide. Something like this. Let's center them just to have it more visually nice. And let's define some spacing between these elements, so something like this. So as you can see, we've added the spacing between our flat components, but also, because we described these template columns, we can increase our screen, and CSS Grid will automatically place as much components as fit based on our condition. So 2 or even 3 or even 4. And again, this is something you can use in CSS right now. There's no library-specific things going on. I think we can do it better. We can think about responsiveness and how these components change depending on viewport. So let's say I want to have a template columns that on medium breakpoint just become 2 columns of 1 fraction of space. So I can go to this breakpoint. Yeah, so I want it to be like this for tablet users. I don't want any stretchy behavior. Now, let's think about this flat unit. We certainly can present it nicer because on tablets we have more width. So how about we create a completely different position of things? So I want to have 2 columns. So left one would be thumbnail, and the right one would be heading and actions. And I can provide this value as areas MD, like this. So things changed immediately. That doesn't look nice. And this is because we need to tell CSS Grid how to deal with these columns right now. So it was 1 column before, but now it's 2. So what is the relationship between them? And we can describe it. We can have the left column to be, let's say, not less than 100 pixels, but more if more space is available. And the right column to be as much as it can take. That's better now. And this min-max is also a feature of CSS, so you can use it. But now if you look at that, this button doesn't look nice. It's kind of floating in the air, and it depends on the content above. So let's just fix it to the bottom. So I can align this section to the flex end. That's much better. So in this short notice, we had the change of behavior from auto placement to this different layout, which is great. Let's think about things we want to render conditionally. I would like to have here a small button that would open the location of the flat on the map. So I would import the only component. And here, where I have my action areas, I would say that I want to render only from medium breakpoint. And I will render a button. And I will just place a map icon inside. So you can see some button popped up. That's interesting. But is it really conditional? Yeah, it is. It's rendered only after medium breakpoint and up. And these areas that we generate and all the components that atomic layout exposes, they share the same props. So I can turn my actions area into flexbox to align these buttons in a row. And I can use prop alias for margin right to just space things between buttons. Oh, this looks nice. And yeah, this is what we have. The component that renders conditionally has its own spacing, but it doesn't break anything here. Now, I would like to ship some new experience for users of laptops and larger screens. And I'm thinking, can I actually reuse, for example, the same definition, but on large screens? We can try. So I can write areas large, and I would provide the same template string here. So let's go to large screens. Something does change. But now, since we're using one column, we don't really need to have two columns here. So this gets in the way. So we can say that we only want this on medium. That's better. And let's also give more air to our design. Let's make it breathe. So we increase the gutter and padding. Oh, gee. Come on. Yeah. So in a nutshell, what happened? We defined our layout. We make an use of auto placement that we have in CSS to fit as much content as possible. Then we dramatically changed the layout without breaking anything. We rendered some parts conditionally, and then we reused the definition we had for larger screens. And this was just a small peek of what you can do with atomic layouts. If you wonder about browser support, it uses React and CSS Grid. So both are very well supported, and as I'm speaking right now, CSS Grid surpasses the bar of 90 to 93% of browser coverage worldwide. So I do encourage you to use it today. It's a great piece of technology, once more. And of course, you can try atomic layout. Just install it through npm install atomic layout and use it in your applications. I hope you can create great things and share your feedback with me. I know that working with something new, especially if it challenges your thinking process, can be very difficult. So I put up a documentation for you, which includes motivations, step-by-step guidelines, and also some useful recipes and best practices. Most importantly, it has resources on CSS Grid, so you can become better at it. Also, check out the GitHub repository for atomic layout. Give me your feedback, submit an issue. Contributors are always welcome. You can even start contributing right now by giving it a star if you liked it. I'm always happy to help you and have a chat, so ping me on Twitter, on GitHub, or read my personal blog for more interesting insights. I really like to hear different opinions and feedbacks and discuss things with people. As a closing notice, I would like to say that in the end of the day, it's not about technologies, libraries, frameworks we use. It's about the journey we experience as developers while learning, changing our mindsets and improving, and also the journeys we create for our customers through building different beautiful apps. So I wish you to have great journeys and create great products. Thank you.